So I wanted to give you a quick and just a quick explanation of section 5.2, which are log functions. There's a lot of words here. It kind of shows you the graph and what the log function looks like, but basically for what we need to know, the log function is a function that has the log in it for log. Okay, there's usually a base. The base, let's see, up here it's defined in terms of a. Okay, it's a number like that, and that's your log function. All right. Just letting you know, we have two special ones. These are the ones that you see on a scientific or graphing calculator, the buttons, when you see a log. So if you see log of x, that is an understood base 10. Now we'll deal with logs with all different kind of bases, but if you see log without a base, it's an understood 10. We call it the common log. And then you also have the thing called the natural log, which is an ln, lowercase ln. That has a natural, a base of the letter, of the number e. Okay, now it's not written, but that's an assumed base of e. These are very important out in the scientific world, enough that they have their own button on the calculator. So we will see these in some of our problems. Just one or two things to tell you. One thing that's important about logs, you cannot take the log of a negative number. Like, this makes no sense whatsoever. This cannot be negative, okay? So later on in a problem, I think that comes up in 5.4, if they're telling you to take the log of -2, that means the solution would be no solution. Okay, this makes no sense. It's only defined, log has to be a positive, right? Positive number, by definition. All right, because logs and exponentials are inverses of each other, they can kind of move back and forth. You can write a log function in exponential function in form, or you can write an exponential function in log form, okay? The way you would do it, and we'll just use this example to show us, when you have to convert from log form, right, to exponential form, which you're going to have to do this over and over again. It's very simple. I like to put the log on the left side and leave my number on the right side of the equal sign. And if you want to convert it, I start with the base, which is 4, and then you're going to do a little circle. We get to 4. That's my next. Let's keep going. We get to equal, and then we get to 256. All right, so this is 4 to the 4 is 256. So it's a counterclockwise motion. Start with the base, which is 4, right? Let's see. We'll do it this way. Okay, start with the base, which is 4, then move around. 4 to the 4 equals 256. 4 to the 4 equals 256. That is the motion. To me, that makes it easier just to remember how to do it. Okay? So that's what they would ask. For this question, they're just wanting you to write it in exponential form. So for the next one, write the logarithmic equation as an exponential equation. They're wanting you to do the same thing, write it in exponential form. So you have the log of 1 equals 0. They're wanting you to convert it. Now remember what I said, when you have log and there's no base, that is an understood 10, right? So if you want to convert it to exponential form, you're going to start with the base, which is 10, right, down there, and then you're going to go counterclockwise like that. So 10 to the 0 equals 1. And that's what they're asking for in this problem. And once again, these homework problems are just, they're wanting you to practice being able to convert. Okay, they're not asking you to solve anything, they're just wanting you to write it in a different form. All right, so we get to these homework problems like this where they ask you to evaluate the logarithm without using a calculator. Okay, the way we want to approach this, we're looking at the log base 3 of the 4th root of 3, and they want us to tell you they want us to tell them what this is. So what you can do is you can sort of create your own equation, we want to know what this is. So if I set this up, log base 3 of the 4th root of 3, so that's a 4. Okay, if you can just set it equal to x, and then we're going to solve for x. Solve for x. So you're kind of creating your own little equation, but solving for x. So the way we solve a log equation is we have to get rid of the log. So what we'll do is we need to convert to exponential. Okay, so I'm going to say convert. First, convert to exponential form. When you do that, you get rid of the log form. Okay, let's do that. Actually, before we convert, let's rewrite the 4th root of 3. Let's see. That would be 3 to the 1/4. Okay? Now, let's convert it. Remember how we do. We start with the base, which is 3. Right? And we're going to kind of curve around like that. 3 to the x equals 3 to the 1/4. So now what we have is we have a problem just like we did in the previous section. We have an exponential equation that we can solve. And if you notice, we have the bases the same, so we can use the relating the basis formula. If 3 equals 3, then we can assume that x equals 1/4. And that's how we work these. Let's look at this one right below too. Okay, evaluate the logarithm without a calculator. So what we're going to do is we're going to set it equal to x, and then we're going to solve for x. Solve for x. All right, so let's come down here. We have, start with 5. 5, right, to the x equals 1/25. Okay, now we have an exponential equation that we need to solve for, and we can relate the bases. We come over here to solve it. 5 to the x. We know that 1/25, 25 is 5 squared. We worked one similar to this before. We need 5 to be up in the numerator, right? So that's 5 to the x equals 5 to the -2, right? Now, because we have, let's see, 5 and 5, we can say that x equals -2. And there we go. So the log base 5 of 1/25 is -2. Okay, I have another video like this posted already, but I wanted to include this since this all fits into this section. These are just some shortcut properties right here that just might help you. Number 1, the log of 1 is 0. That's basically saying if I ever ask you the log of any base, doesn't matter the base, of 1, you automatically know it's always equal to 0. Always. Doesn't matter what base at all. Okay? You can prove that if you wanted to. If you converted it to exponential form, that would be 8 to the 0 equals 1. The only way you can raise 8 to an exponent and get the number 1 is if that exponent is 0. Okay? So the other two just basically goes to show you if you have the log base 8 of 8 squared. This is just an example. When you have the log and the base is 8, and then you have 8 squared, which that's also the base. If the bases are the same, which in this case are the 8s, you can assume the answer is that exponent. Once again, this is just a shortcut way that you could solve some of the problems. If you didn't want to do it that way, you could set it as an equation and solve it that way. And likewise, the third one, C, this is just saying if you raise, we'll do another base like 7 to log base 7 of 3. Once again, the bases are the same. If I highlight them, that and that, those are the same. And when that happens, the answer is 3. Oops, I need to change 3. They really are. They're shortcut properties that might help. All right, let's look at a few down here. zoom in. Okay, the first one, 3 to the log base 3. Once again, you see the 3's are the same, so the shortcut property, you can just look at it and you know it's 8, which is nice. Let's look at this log base 2 of 16. Okay, using this, you can rewrite. We know that 16 is 4 times 4, or 2 to the 4th. Okay, so I've rewritten 16 as 2 to the 4th. So because of these shortcut properties, since my bases are the same, I know that 4 is my answer. So log base 2 of 16 is 4. If you didn't want to do that, that's fine. Look, you could do this just like we've done. You could set it equal to x and solve it. Convert it to exponential, right? Remember, you'd start with 2 to the x equals 16, and then you solve it from there. 2 to the x, 2 to the 4, x equals 4. Okay? These are two different ways of solving the same problem. Okay? The first one I showed you is just a shortcut. Okay, let's look at the second one. Natural log. I'm going to rewrite that. This is e to the 5/8. Okay, now remember, natural log is an understood base of e. It's just never written. So now we can use the shortcut like the second one that was given. Since you have the e's or the bases, we know that the natural log of e of 5/8 is just 5/8. All right, and finally, log base 7 of 1, like I said, the log of 1 is always 0. I hope this helps. I know it's a few problems, but it might help you get through some of your homework, and I just hope seeing it and listening to me talk about it might help you through some of your problems.